Is it clear now? Okay. So good afternoon all of you. So in the previous classes we have completed case 1 and case 2. As you all know, we are doing the revision of unit 3. In unit 3 we have learned how to find complementary function in different cases. As you all know, we find complementary function when the roots are real and distinct, when the roots are real and equal, when the roots are complex, or we can also say that when the roots are real and imaginary. We learned how to find complementary function, and then we have turned to next topic, that is particular integral. In that particular integral we have started case 1 and case 2. We have completed case 1 and case 2, and now today we do case 3. That is nothing but here, as I have told you, in particular integral, the particular integral will be of the form yp is equal to 1 upon f of t into capital X. So as you know, if a problem is given, solve, some f of d will be given into y is equal to capital X will be given. By seeing capital X we come to a conclusion it is of which case. Okay, so now let us do case 3. Here let us see what will be the case 3. What will be case 3? Case 3, in case 3, capital X will be, capital X is equal to x power m, comma, m is positive integer. M is positive integer. Okay, so here when you find capital X is equal to x power m, m may be a positive integer. So as you know, positive integer is nothing but greater than 0. So now here there is a procedure to find in case 3. There is nothing but, when a problem is given in case 3, how to do to find particular integral, comma, first we reduce f of d of the form or to the form 1 plus phi of t by taking least degree term of capital D as common. Okay, now if particular integral is equal to yp is equal to 1 upon f of d into x power m, that is equal to 1 upon 1 plus phi of d x power m, that can be equal to 1 plus phi of d whole power minus 1 x power m. Okay, then using binomial expression or binomial expansion, we can find the above value. So here why I am writing this all is, so if you once you see this, then when you go through the problem, then it will be easy for you and you can understand. So let us do a problem based on this. This is the procedure. As I have told you, in case 3, capital X will be in the form x power m, and then we reduce f of t in this form, and then after that we take in numerator so that it becomes power minus 1 into x power m. Then we use binomial expansion, and then we multiply with x power m so that we get the answer. Now let us do the problem first of all, if you want, we'll have expansion also. Already you have in notes. I don't want to write all the expansions. That is nothing but 1 plus x whole power minus 1, 1 minus x whole power minus 1, 1 plus x whole power minus 2, and so on. We have that are all already. You have in your notes. So I don't want to write again that. We will directly go to the problem. So now the problem is, first we'll write problem solve d square minus 3d plus 2 into y is equal to 2x square. So this is a problem. Okay, if a problem is given in this way, now in the solution, let me do, as you know, the problem will be in the form of f of d of y is equal to capital X. By seeing capital X, you can see this is a capital X. Capital X is in the form here, 2 is constant, you just neglect that. Now you can see x square is there. So x square is in the form of x power m, as we have written here, x power m. So if it is given, so we have to assume that this is a third case. So then by taking this as third case, we have to apply the procedure which we have written in the above. So now first we find here particular integral complementary function. So let us write first given. What is given? Let us write d square minus 3d plus 2 of y is equal to 2x square. As you know, this is in the form of f of d of y is equal to capital X. Okay. Then after writing that, now we write auxiliary equation. As we know, we take this as equation 1. After taking equation 1, we write auxiliary equation of 1 is f of m is equal to 0. As you know, f of d is nothing but d square minus 3d plus 2. I am writing here m square minus 3m plus 2 equal to 0. Then we find roots. As you know how to find roots here. So I can take m square minus 2m minus m. Minus 2m minus m is minus 3m. Minus 2m into minus m is nothing but 2m square you get, plus 2 is equal to 0. Implies you can take common now, m minus 2, then you get minus 1 into m minus 2. Then we can write this as m minus 1 into m minus 2 is equal to 0. Then m minus 1 is equal to 0, m equal to 1, comma m minus 2 equal to 0, m equal to 2. So you got roots 1 comma 2. After that we find complementary function. Therefore complementary function c dot f is equal to yc is equal to, as you know, the roots are real and distinct. If the roots are real and distinct, we can write c1 e power m1x plus c2 e power m2x. As we have two distinct roots, we are writing, we limit up to 2 here, m1 and m2. If you have another root, you can extend up to n if you have. So now here I am writing, as you know, these two roots are nothing but m1 is equal to 1 comma m2 is equal to 2. Now we can directly substitute in complementary function, that is c1 is equal to e power 1 into x is x, m1 is nothing but 1, 1 into x is x, plus c2 e power m2 is nothing but 2, 2 into x is 2x. This is nothing but yc. So we got yc. Now we find particular integral. One thing you have to remember, that if a problem is given, find the particular integral of some problem is given, then you have to find only particular integral. There is no need of finding complementary function. If a problem is given like solve and a problem is given, then you have to find complementary function as well as particular integral. Now here most of the cases in the exam will ask find the particular integral of a problem is given. So in that case you have to find only particular integral. There is no need of finding complementary function. So now here, now we are finding particular integral now. As you know, particular integral is denoted with yp. Yp is equal to, you know how we write first, f of t into capital X. As you know, this is standard for every case. We have to write this first. And then after writing that, we write yp is equal to 1 upon f of d. F of d, as you know, f of d is given d square minus 3d plus 2. into capital X is nothing but 2x square is given. You have to write 2x square. After writing that, we have to take the least degree term as common. So if you take least degree term as common, then this becomes, here I can write this as 2x square in numerator, and then in the denominator I am taking least degree term, that is nothing but 2 here. So if you take 2 common in bracket, we get 1 plus d square minus 3d upon 2. You have to put in bracket. This 2 I am taking common, and then you can see, you can write, we have plus 2, so we can write anywhere. So 2 into 1 is 2 plus d square minus 3d upon 2 we have to write, because we are taking 2 common. Okay, so this is the way how we write. After writing this, now you can see here, you can cancel 2 and 2 here. Now the next term will be x square upon 1 plus d square minus 3d minus 2. So after writing this, now you get, we can take this the whole term in numerator. If you take in numerator, then this becomes 1 plus d square minus 3d upon 2 whole inverse into x square. I am taking this denominator in numerator so that it becomes whole power minus 1 into x square. After writing this, this is in the form of a binomial expansion, that is nothing but 1 plus x whole power minus 1. 1 plus x whole power minus 1 is nothing but 1 minus x plus x square minus x cube plus and so on. So as you know, here we have to consider this whole term is nothing but x. So this is nothing but 1 plus x whole power minus 1. Now we apply this expansion. If you apply this expansion, then you get 1 minus x is nothing but d square minus 3d upon 2 plus, again we have d square minus 3d upon 2 whole square minus and so on. You can take any 3 terms, or any, you can take another term also, no problem. So after this, after taking this, now you can expand inside. If you expand inside, you get 1 minus d square by 2. You can separate the terms also. Here we have minus d square by 2. I am writing minus into minus plus 3d upon 2, then plus, now you can expand this, that is nothing but a minus b whole square, that's nothing but you get d square by 2 you have. So if you square that, you get d power 4 upon 4. Then we have a plus a square plus b square. B square is nothing but here 3d by 2 we have. So if you square that, then you get 9d square upon 4. Then a square plus b square minus 2ab. 2ab is nothing but 2 into d square by 2 minus 3d square by 2. So you get 2ab is nothing but you get it's, I think so you can leave that also, because if you take the higher term, if you differentiate that, this becomes 0, so you can take and so on. So put the bracket here, and then we can write x square also. Okay, so then if you multiply inside, this becomes x square, then minus d square upon 2 into x square plus 3 by 2 into d of x square plus d power 4 of x square upon 4 plus 9 d square of x square upon 4 minus and so on, because the higher term we won't take, we neglect higher term here. Now because why we neglect higher term is, where you differentiate twice 4 times, it becomes 0, so we will get higher term, so that's why we neglect that. So now here the next step will be, here x square is x square minus, when you differentiate x square twice, you get, well, once if you differentiate you get 2x, Again if you differentiate, that becomes 2. So we write here 2 by 2. Is it okay? Once see here, when you differentiate x square twice, you once if you differentiate d by dx of x square is 2x. Again if you differentiate 2x is nothing but 2, so you get 2 by 2 plus, now when you differentiate this you get 2x, because only one time we have to differentiate this, so 3 by 2 into 2x, 3 by 2 into 2x, so you get 3x, that's it, because 2 get cancels here, 2x you get 2 get cancels, only 3x will be there, plus this term becomes 0, because when you differentiate 4 times x square becomes 0. Then we have next term is when you differentiate d square, if you differentiate d square, then you get when you differentiate x square twice, again you get 9 into 2 upon 4 minus and so on, be x square minus 1 plus 3x. Now you get 2 ones are 2 twos are, so you get minus 9 by 2 minus and so on. So this will be the answer. Here you can see, here we have minus 1 minus 9 by 2, isn't it? So if you have this one, you can just simplify the constant terms, so that you can get x square plus 3x. Now here you can see this one, this becomes minus 2 minus 9 minus 11, this will be plus, okay, yes, this is plus, so this is plus, here we have plus here, so we have to take plus, here we have plus, okay, good. So now plus 9 by 2 minus 1, that is nothing but plus 7 by 2 you get, because you can see here if you cross multiply, like minus 1 plus 9 by 2 we have, so now if you cross multiply and take the LCM, you get 2, so minus 2 plus 9, so that becomes 7 by 2, so you get 7 by 2. So this is the particular integral. Now we find this is particular integral. Now we find general solution. General solution is y is equal to yc plus yp, you know this. Now y is equal to, you know, as we have got complementary function just now, complementary function is nothing but, here you got c1 e power x plus c2 e power 2x, so we write here c1 e power x plus c2 e power 2x, by seeing complementary function we are writing. After that, yes, can you see now bottom of the paper? No. Now c1 e power x plus c2 e power 2x plus particular integral will be this one, x square plus 3x plus 7 by 2. So this is the general solution we get. Okay, this is the case 3. So in case 3 we do problem. In every problem of case 3, when capital X is x power m, we have to take in this way, as you can see just now. And just once again I will repeat, when you find the problem is in case 3, then we have to write first, this is a standard form, 1 upon f of d into capital X, then we have to write 1 upon whatever f of t will be given in the problem, we have to write here, then capital X should be written here, and then in numerator anyhow you will have x power m, then in the denominator you have to take the least degree term as common. After taking common, so you will get in this form. After taking in this form, if it cancel, here it is we can cancel 2 here. After cancelling, whatever denominator term we have, that should be taken to the numerator, that becomes 1 plus x whole power minus 1 into whatever x power m will be there, that should be multiplied with that. After that, we have to take the expansion. If it is 1 plus x whole power minus 1, then you have to take this formula, this is the binomial expansion, and then after that you can write in this expansion considering this as x 1 plus x. Now we have written in this expansion. After writing that, in expansion, if there is a possibility of taking a minus b whole square or a plus b whole square, you can take and you can multiply inside with minus or plus, so that you can get this. After getting this, you can multiply whatever x power m is given, that should be multiplied inside. After multiplying, you can differentiate. If it is d square, then you differentiate twice. If it is d power 4, you differentiate 4 times, and so on. After differentiating, you get some terms, and see that if there is a possibility of adding or subtracting, here x square is only one time, you will write here x square, then we write 3x. Then there is a possibility of adding or subtracting constant terms. Here we have minus 1 plus 9 by 2, so we have subtracted this, so that we got plus 7 by 2. Then after getting that, whatever term we got last, then directly we write the general solution is y is equal to yc plus yp, then you know complementary function plus particular integral. This is about case 3 first problem. Let us go for another problem so that you can understand. So let us have second problem now in this case 3. In case 3, second problem is solve d power 4 minus this is d square minus 4d minus 4d plus 4 into y is equal to x cube. Okay, this is the problem. Now let us write given first. This is given is nothing but d square minus 4d plus 4 into y is equal to x cube. Okay, so after writing this, now as you know, we have to take the roots, we have to find the roots by taking auxiliary equation. Auxiliary equation of 1 is f of m is equal to 0, as we are taking this as equation 1. Now this becomes m square minus 4m plus 4 is equal to 0, implies this is in the form of a minus b whole square, that is nothing but m minus 2 whole square, m minus 2 whole square equal to 0. Now roots becomes m minus 2 into m minus 2. I can write m minus 2 whole square as m minus 2 into m minus 2 equal to 0. M is equal to 2 comma 2, we get 2 roots. You can see here we have written in a minus b whole square, as you can see a square plus b square minus 2ab is nothing but minus 4m. So we got m equal to 2 comma 2. So now after writing this, we will find complementary function, that is nothing but yc is equal to nothing but, as you can see, the roots are real and equal. Here we got 2 comma 2. You can see roots are real and equal. So when the roots are real and equal, you have a formula for finding complementary function, that is c1 plus c2 x into e power m1x. m1x is nothing but m1 is nothing but 2 here, 2x. So as you all know how to find complementary function, I am writing here directly. Now this is about complementary function. Now we find particular integral. As you know, particular integral can be written as yp is equal to 1 upon f of d into capital X. So here this is equal to 1 upon f of d is nothing but, we can write d square minus 4d plus 4 into capital X is nothing but only x cube is given, that we have to write. So after writing that, again we can write this in the form of a minus b whole square, or in the previous we have written there is nothing but 1 upon, I can write this as 1 upon f of d, I mean a square plus b square minus, you can write this in this form, or you can take 4 common. So if you take the least term common, we can write 1 plus d square minus 4d upon 4. Either you take a minus b whole square, that is nothing but d minus 2 whole square, or you can take least term as we have done in the previous problem. I don't want to confuse here. When you are finding particular integral, in f of d we have to take the least term as common, so we have taken least term common. After taking least term common, 4 into 1 is nothing but 4. Again 4 into this term is nothing but you get d square minus 4d into, here I can write in numerator, that is x cube. Okay, after writing this is equal to, now I can write this is equal to 1 upon 4 into, I can write the whole term in numerator, that is nothing but 1 plus d square minus 4d upon 4, close the bracket, then whole power minus 1 into x cube. Now this has become the expansion for 1 plus x whole power minus 1 again. So when it is a expansion of that, just now we have done the same for the same expansion, that is nothing but 1 plus x whole power minus 1 is nothing but 1 minus x plus x square minus x cube plus and so on. Now let us write in that expansion, so this becomes 1 upon 4, and in bracket if you see this is nothing but 1 plus x whole power minus 1, so I can write in bracket 1 minus d square minus 4d upon 4 plus d square minus 4d upon 4 whole square minus and so on, close the bracket, into x cube. Now after writing this is equal to 1 upon 4. Now multiply or expand this first. So if you expand this becomes d square upon 4 minus into minus plus, you get 4d by 4, 4 get cancels, you get only d plus then you expand this. If you expand this you can get d power 4 upon 16. Okay, d power 4 upon 16 plus b square is nothing but 16 d square upon 16 minus 2ab, 2 into ab is nothing but, here you can take d square by 4 as a, 4d by 4, so you can neglect that also, no problem, and so on. Just close the bracket, x cube. Okay, so then after that you just multiply x cube inside, so that it becomes 1 upon 4. Now x cube into 1 is x cube minus d square upon 4 into x cube plus d into x cube plus d power 4 upon 16 into x cube. Then you can cancel 16 here, so you get only plus d square into x cube minus and so on. Okay, so after taking that, now neglecting the higher term, you don't want to write and so on, just leave that. So now I can write now 1 upon 4. Now in bracket you get x cube, now minus, when you differentiate x cube twice, once if you differentiate d by dx of x cube is 3x square. Now again if you differentiate 3x square you get 6x, so you get 6x upon 4 plus, when you differentiate x cube once you get 3x square, then plus when you differentiate x cube 4 times, then you get 0, because when you differentiate d square x cube twice you got 6x. Again if you differentiate 6x, that becomes 6. Again if you differentiate, that becomes 0, so we can get 0 here. Then plus, now if you differentiate x cube another twice, then you get 6x, okay, minus and so on. So after getting this, now we can write this is equal to 1 upon 4 in bracket x cube plus 3x square. Then you have both x terms here. Now I can take minus 6x plus 6x, how much? Minus 6x, 4 goes there, that becomes 24x, minus 6x plus 24x plus 18x upon 4. just close the bracket now. There is no need of taking again because higher terms can be neglected. So here someone has asked topic name. Topic name, we are doing problems based on particular integral. This is case 3. And another question is, sir, after 1 how many terms is compulsory? After 1 you can take 2 or 3 terms like x square, enough. So you can take if you want to take another term, you can expand. That will be somewhat complicated. Don't write another term. So though 2 terms are enough, x and x square, and then you can expand and just multiply inside and differentiate. That will be enough. That will be the answer. So now if you differentiate x, it should not be 0. It may be 0. If you differentiate x twice or thrice, you can, here if you differentiate x cube, we will get 0. Here you can see, here x cube, we have to differentiate here d power 4, that is d power 4 by dx power 4. When you differentiate the x cube 4 times, it becomes 0. So we have to write 0. Another question, if we differentiate x, it should not be 0. There is nothing like that. It may be 0. Till then we can differentiate. So here based on the power of d, we differentiate here. Okay, there is nothing like we have to make it 0 or something like that. So here based on the expansion, based on here you can see, based on this we will do. So this is the term we get now. Inside if you multiply with 4, you get x cube upon 4 plus 3 upon 4 x square plus, now you can cancel here 4 ones are, and here I can cancel. Here you will get 9 by 2. 9 by 2 you get, so you get 9 by 8x, because 2 ones are 2 nines are, and we are multiplying with 1 by 4, so you get 9 by 8x. So this is yp. Okay, so this is yp. Now we will find a particular we find general solution now. So general solution is nothing but y is equal to yc plus yp. We write here general solution. General solution is y is equal to yc plus yp. So now y is equal to, yc is nothing but, we got 2 roots, both are equal, so we have written complementary function as c1 plus c2 into x into e power 2x plus particular integral just now we got, that is nothing but let me see, x cube by 4, x cube upon 4 plus 3 by 4 x square, 3 by 4 x square plus 9 by 8 x, 9 by 8 x. So this is the answer for case 3. In this way we do the problems based on case 3. Hope you have understood. Now let us go for next case 4. If you have any doubt in case 3, you can ask. Let us go for case 4. Now let us go for case 4. Hope you have understood. Now let us go for case 4. So at last we will have recap in how we have what are the cases we have done, and what will be the capital X in each case. Once we will do we will have at last we will go through that. Now case 4 is nothing but if capital X is equal to e power x into v. Okay, where v is a function of x, then particular integral will be of the form, particular integral yp is equal to 1 upon f of d e power ax into v. So if it is a case, then we write yp is equal to e power ax 1 upon f of d plus a into v. So in this way we write case 4. Let us do the problem so that you can understand. Now first problem is solve d square minus 4d plus 3 into y is equal to e power x cos 2x. Okay, so this is the problem. Now as you all know how to find particular complementary function, now let us find directly the particular integral here so that we will complete this soon. Now for finding particular integral, now we know particular integral can be written as particular integral is equal to yp. Assume that question is asked like find the particular integral of d square minus 4d plus 3 into y is equal to e power x cos 2x. Instead of solve, I am writing directly yp. We are finding yp. As you all aware how to find complementary function, I am doing directly particular integral. Particular integral, as you know, in this procedure, as I have told you, when capital X is given e power x into v, like you can see e power x into v, v is a function of x, then you have to assume that this is case 4. Now if it is the case 4, now particular integral will be written in the form 1 upon f of d into e power ax into v. So in the next step we will write what is given in the problem. 1 upon f of d is nothing but d square minus 4d plus 3 into e power x into cos 2x. In this way we write. After writing this, now when you are taking e power x to this side, now you can see here e power, it should be e power ax. A is nothing but 1 we have to consider because it is given e power x. So a is 1. So if you can see here in the particular integral procedure, it is given when you are taking e power x to other side, then you have to write this a as d plus 1. Okay, because that is here you can see here we have written d plus a. So in the same way we are taking e power x to this side, and I am writing in the place of d as d plus 1 whole square. Based on this a, we write here d plus a whole square minus 4 into d plus 1 plus 3 into cos 2x we write. Then after this we will expand whatever given in the denominator, like e power x into 1 upon, now you can expand a plus b whole square, that this becomes a square plus b square plus 2ab. A square is d square, b square is 1 square plus 2 into 1 into d minus, multiply this 4 with d plus 1, that becomes minus 4d minus 4 plus 3 into cos 2x. Then this becomes e power x 1 upon, now you can multiply or you can write the d square first and then d terms, plus 2d minus 4d is minus 2d. Then we have constants here, 1 minus 4, that is minus 3 plus 3 becomes 0 plus 0. So then we have cos 2x, you write in cos 2x. Okay, now you can see here we got d square minus 2d. Okay, is it okay? Yes. Now next, after this, in the next step, if you have any doubt you can ask me. Just here in the place of a we have 1, so in the place of d we have to write d plus a. So as a is 1, so we are writing d plus 1 whole square. Again here we have d, so we are writing d plus 1. Here we have 3, we are writing 3, and then we are expanding and simplifying, we got this. After this, in next case, in the next step we write like you get this is equal to e power x 1 upon, now we will have only d square minus 2d because constant has become 0. So d square minus 2d cos 2x. So now Mostly in case 4, you will, when after applying d plus a, you will get that in the form of case 2. You can see this is case 2 now. 1 upon f of d square into cos ax plus b. So b is 0 anyhow. You can see here it is cos bx. This is case 2 now. So when a case 2 is we get now we will apply the procedure of case 2 now. In case 2 we will write d square is equal to minus a square, as you all know. So here I can write the place of d square minus 2 square minus 2d into cos 2x. You can see this is 1 upon f of d square into cos bx. We are writing d square is equal to minus a square, that is nothing but d square is equal to minus 2 square. That I am writing here. In the place of d square I am writing minus 2 square. Okay, so minus 2d cos 2x. After writing this, this is equal to e power x 1 upon, now you can write 2 square is nothing but 4, so I can write minus 4 minus 2d into cos 2x. Okay, then after this you can take common also, so this can be written as e power x 1 upon, you take common as minus 2. If you take minus 2 common, then this will be inside you get 2. You can see minus 2 into 2, that becomes minus 4, and then here you have minus 2d, so I can write here plus minus into plus minus 2 into d, just we have to write d here, and then cos 2x. Okay, then after this we can write this as constant, like minus 1 by 2 I am writing first, and then we are writing e power x, and then the term we left is 2 plus d into cos 2x. Now if it is the case, now you have to rationalize. As you know, in case 2, after substituting d square is equal to minus a square, there is a possibility of getting this type of term. That term we rationalize in every problem of case 2. So here you get 1 upon, that is nothing but I am writing here. After rationalizing, you know, if you have in denominator 2 plus d, so I can write you get 2 a plus b into a minus b, that is 2 plus d into 2 minus d. Here we have cos 2x. Okay, so what I am doing here, just I am taking here 2 plus d is there, so into 2 minus d upon 2 minus d, so this can be in the form. So now this can be written as, this is equal to minus 1 upon 2 e power x 2 minus d upon a plus b into a minus b, that becomes a square minus b square, a square minus b square, so that is d square into cos 2x. Okay, so now in the next step you can write this implies 1 minus 1 upon 2 e power x into 2 minus d into cos 2x upon 4 minus d square. Okay, then after this we can write here again d square is equal to, again we have to write minus a square, so we write this is equal to minus 1 by 2, okay, e power x, now 2 minus d into cos 2x upon, now again this is in the form of case 2. So in the case 2 we write d square is equal to minus a square, so we write 4 minus, in the place of d square I am writing minus a square, a is nothing but 2 here again, so that becomes, in bracket we can write minus 2 square, only 2 square, square is for only 2, not for minus. Now this implies you can write minus 1 upon 2 e power x in bracket 2 minus d into cos 2x upon, we can get 4, now minus into minus is plus 4, now this is equal to, you get 4 plus 4 is 8, 8 into 2 is minus 16, so that is nothing but minus 1 by 16 you get e power x, now 2 minus d into cos 2x. this denominator we have multiplied with this 2. So as you know, 4 plus 4 is 8, 8 into 2 is 16. So we got minus 1 by 16 e power x, and then 2 minus d cos 2x. After this we can write this is equal to, here I am writing minus 1 by 16. You just here itself I can write 1 upon 16 e power x. Now you multiply cos 2x inside. If you multiply cos 2x inside, if you multiply 2 into cos 2x, you get 2 cos 2x, then minus d into cos 2x. What do you get? D into cos 2x. Close the bracket. Now in the next step, minus 1 by 16 e power x, in bracket you get 2 cos 2x minus, here you can see we have capital D. Capital D is nothing but d by dx, small d by dx. So d by dx of cos 2x, when you differentiate cos, you get minus sine 2x. Again if you differentiate 2x, you get 2. So the result will be minus of minus plus 2 sine 2x. So this is the particular integral we get. If you want, if you can take common 2, you can take, so minus 2 by 16 e power x in bracket cos 2x plus sine 2x, or you can take, this is equal to, you can cancel this. If you cancel, you get 2 1s are 2 8s are, so minus e power x upon 8 in bracket you can get cos 2x plus sine 2x. So this is the answer for the problem. So this is about case 4. In case 4 we are applying applying case 2 mostly. So here in the starting, just we are taking, that is nothing but you can see whatever a is given, with that a, wherever d we have, we are substituting d plus a. As you know, in this problem it is a is 1, so in the place of d we are writing d plus 1, and then in the place of d we are writing d plus 1. Then we are simplifying. After simplifying, we are getting this step. After that, you can see in the next step we are writing in this way. After getting this is in the form of 1 upon f of d square into cos 2x. You can observe this can be case 2. So we are applying the procedure of case 2. In case 2 procedure, just we write d square is equal to minus a square. As you know, a is nothing but 2 here. A is nothing but 2, so we are writing d square is equal to minus 2 square. So we are substituting here, so that you get this minus 4 minus 2d into cos 2x. And then after that we are taking minus 2 common from this. After taking minus 2 common, you are getting 2 plus d. So you can see here I have written here 1 by 2 plus d cos 2x. So this can be rationalized now. When you rationalize, you get 1 upon 2 plus d into 2 minus d by 2 minus d into cos 2x. That can be written as 2 minus d. Now 2 plus d into 2 minus d is nothing but a plus b into a minus b. That can be written as a square minus b square. So then we have written in this way. After that we have written again, this has become again case 2. So here you can see we have d square. So we have substituted again d square is equal to minus a square. A is nothing but 2 here. So in this way we have solved the problem. Yes, there is a doubt here. No, that's what I am saying here. He's asking that here this is minus 2 whole square. This square is for only 2. As you know, d square is equal to, as I have told you, minus a square. Minus a square. Minus is different, a square is different. So here minus a is nothing but 2. So we are writing 2 square. Only we have to square 2, not for minus. So that's why we are writing here minus 2 square. This minus has become plus here. Minus of minus plus 2 square is 4. In this way we do. In every problem we do in this way only. We substitute in this way and then we will proceed. Don't do mistake like minus 2 whole square. Minus 2 whole square, that becomes 4. Again you will get 4 minus 2. That will be wrong. Okay. Hope you got. So let us go for next problem. Let us do another problem in case 4. Shall we do next problem or we'll go for next topic? Please post the comment. Two is under. What is 2 is under here? Here I am writing here, if you have minus 2 whole square, that can be written as 4. This is minus 2 square. Square is for only 2, not for we are not squaring for minus. Okay. So another problem. Let us go for another problem. We'll complete in 5 minutes. So let us go for next problem. Yes. So next problem is, we'll find only particular integral. It will be over in 5 minutes. Now let us write the problem. So the problem will be asked, find the particular integral of t square minus 2d plus 1 into y is equal to x e power x sin x. This is the problem. Okay. So when a problem is given in this way, now solution will be, you can see there is a somewhat you will get trouble in finding problem. Okay. So when you have x e power sin x, now you have to assume this is in the form of, this can be considered as e power ax into v. E power ax into v is nothing but sin x here. Okay. So now the problem is given, particular integral we write directly. Particular integral is equal to yp is equal to 1 upon f of d e power ax into v. Okay. Now this can be written as 1 upon f of t is nothing but t square minus 2d plus 1 into e power x is nothing but, here it is given x e power x sin x, isn't it? So in procedure of case 4, so it is asked to put in the place of d as d plus 1. So you can write e power x here first, and then we write 1 upon, in the place of d we are writing d plus 1 because a is 1 here also a is 1, so d plus 1 whole square minus 2d plus 1 into x sin x. Okay. So after that, this can be written as, this is equal to e power x 1 upon, now you can expand d plus 1 whole square and this one, so this becomes d square plus 1 plus 2d minus 2d minus 2 plus 1 into x sin x. Okay. Now this is equal to e power x 1 upon, now you can see here 2d get cancels here, and the thing is here you can see the term will remain d square. Now 1 minus 2 minus 1 minus 2 is minus 1, you get minus 1 plus 1 get cancels, right? Wait a minute. Yes. So you get shall I write here plus 0? Okay, 0, you will get 0. Then we have x sin x. Okay. Now this is equal to, now you can see e power x, I am writing again 1 upon, you are getting only d square here, and then x sin x. Then as I have told you in the previous starting of the unit, when we are starting particular integral, I have told you 1 upon d is equal to integral. When you get 1 by d, that can be considered as integral, and d I have told you to take as d by dx. This should be remembered when you are doing unit 3. Okay. So we need here 1 upon d is integral, so we write here e power x into 1 upon d, I am taking 1d here, 1 upon d x sin x. Okay, so now, so you know 1 upon d is nothing but integral, so 1 upon d in bracket I can write integral of x sin x dx. Okay, integral of x sin x dx. Now you can apply integration by parts formula. Now integration by parts formula is nothing but, here you can write e power x into 1 upon d in bracket I can write x, integral of sin x is nothing but minus cos x, then minus integral of d by dx of x is 1, again integral of cos x, minus cos x you get, when you integrate you get minus sin x, you get minus sin x. Just close the bracket. If you want I'll write and do, if you don't understand. As you know, you have a formula like integral of u v dx is equal to u integral of v dx minus integral of u dash in bracket integral v dx integral dx. So this is the formula we have for finding integration by parts. As you know, we are applying isolate rule. As you know, isolate is nothing but, here you can see x is algebraic, okay, sin x is nothing but trigonometric, so it is in order, so this is u and this is v. So when you substitute in the formula, if you substitute in the formula you get the above step what I have written. Okay, so then this step will become e power x into 1 upon d, and in bracket you get minus x cos x, then minus of minus plus sin x, okay, sin x, this you get minus x cos x, minus of minus plus sin x. Then again we have to integrate, you can see 1 by d it is given, so e power x integral of, in bracket you can write integral of, I can write separately because we have in between we have plus, so we can write minus outside x cos x, yes, x cos x dx plus integral of sin x dx. Again here you have to apply integration by parts formula. This is the same formula. Now here again this is u and this is v. So if you apply integration by parts formula, this becomes e power x, in bracket you get, if you want to take you can take minus with x only, so that it will be with this. So minus x in bracket, if you integrate, that is nothing but integral of cos x is sin x, we write sin x here, then minus integral of u dash is nothing but minus x, so minus x d by dx of minus x is minus 1, so you get minus 1 here, I'll write minus 1, and then if you integrate cos x, that becomes what, sin x, again if you integrate with this, so you get minus sin x, so we write we get minus cos x, okay, minus cos x, yes, minus cos x, then integral of sin x is nothing but minus cos x, okay, so you get this step. Now after this, now just simplify this becomes e power x, then in bracket you get minus x sin x, then minus into minus plus, plus into minus minus, so you get minus cos x, then again we have minus cos x, minus into plus minus, plus minus cos x, yes, this you get. So now after this just close the bracket and we'll write the last step in the back, yes, here you get, now you can see here the last step you got this one. Now this is equal to e power x in bracket minus x sin x minus 2 cos x you get, because here cos x minus cos x minus cos x, you get minus 2x minus x sin x, so you take minus outside, this becomes minus e power x, in bracket you get x sin x, then you get here plus 2 cos x, okay, so this is nothing but yp, this is yp is nothing but particular integral. So in this way we find the problem. So it's not compulsory that you may get the case 2 here, you may the problem will be different. When you see here, we got here d square, only d square you got. As I have told you, 1 by d is nothing but integral. So we have used here integration by parts formula to solve the problem based on case 4. Okay, so this is about case 4. Now regarding, so it is 4 already. Shall we go for next topic, or shall we go for next topic? Please post. Shall we take half an hour more? Okay, let us write case 5. Case 5. So case 5 is nothing but, I am writing case 5 now. If capital X is any other function of x, then resolve, okay, then resolve f of d into linear fractions. Yes, we are taking next topic. So we'll have case 5. This is the last case in this case, in this third unit. So, and then after this we have 2 topics, that is the method of variation of parameter and the Euler's Cauchy. Let us complete this. So case 5 will be completed today. Tomorrow we may take method of variation of parameter as well as Euler Cauchy. So this is about, so I may give the quiz questions today or tomorrow, so that we will take a quiz also as internal exam. Maybe tomorrow or day after tomorrow. We will complete in this week mostly. So if capital X is any other function of x, then x is nothing but small x, then then resolve f of d into linear fractions. That is, f of d is equal to d minus m1 into d minus m2 and so on, d minus mn. Then particular integral is equal to yp is equal to 1 upon f of d into capital X. Then after this we write yp is equal to 1 upon d minus m1 into d minus m2 and so on, d minus mn into capital X. Now this can be written as a1 upon d minus m1 plus a2 upon d minus m2 plus and so on, plus an upon d minus mn in bracket capital X. Okay, so this is in the form of partial fraction. We are doing partial fraction here. So this I have not done in the classroom, because most of the cases in the most previous papers we have got problems based on up to case 4. So I don't want to take any risk, so we are doing this problem also, because case 4 we have completed. This is case 5. So case 5 let us complete, so that there is no chance of so this is the procedure I am writing here for your convenience. So you can take after completing the class, you can take from the video also. I am saving on the page. So this is the procedure of case 5. So hope I have given you the notes. This is nothing but case 5. So once check it in the notes whether it is there or not. If it is not given, so you just write it in the notes. Okay, so in this way we do the problem. Yes, I have done only 4 cases. Okay, so take down, this is the 5th case, that is the last case. I don't want to take any risk, so I thought that only 4 cases, from the 4 cases problems are asked, so I thought to do only 4 cases, but there is a time now, so let us complete case 5 also. Only case 5 cases are there in this unit, so we are doing case 5 also. So now this is case 5. Okay, this is the procedure. Now let us do the problem so that you can understand what is given here. Okay, now let us write the problem based on case 5. Case 5 problem is solve d square y upon dx square plus y is equal to cosec x. This is the problem given. You can see the problem is in the form of d square y, so let us write in operator form now in the problem. So you want procedure to be explained? Okay. So here here you can see the capital X in this case 5 will be any other function of x. Then we have to resolve f of d into linear partial fraction. So f of d will be in this form will be given d minus m1, d minus m2 and so on, this one. So f of d will be, if a particular integral will be written, as you know, this is the standard form, that is 1 upon f of d into capital X. So here we are writing whatever f of d is given in the problem, we'll write here, we'll have capital X. So capital X will be a function of x, and then after writing this one, we have to write this in terms of partial fraction. After writing in terms of partial fraction, we have to find a1, a2, okay, and then we have to multiply with x. After that, we have to write this as a into em1x into this one. This is the step we have to follow at the end. Let us see in the problem so that you can understand. So now here given, what is given here? Given in operator form, we'll write here given in operator form, or we can write in operator form is, don't write given, so write in operator form. In operator form, if we write this becomes d square y plus y is equal to cosec x. Okay, so after this you can take this as equation 1. Now you can write this as d square plus 1 after taking y as common is equal to cosec x. Okay, now auxiliary equation is f of m is equal to 0, implies what you get, m square plus 1 is equal to 0. So m is equal to, you get plus or minus I, because m square is equal to minus 1, m is equal to plus or minus under root of minus 1. Under root of minus 1 is nothing but I, we have plus or minus. Now you can see this is in the form of 0 plus or minus I. Okay, so this is nothing but in the form of alpha plus or minus I beta. Okay, so alpha is nothing but 0, beta is nothing but 1. So when you have your roots in complex or real and imaginary, then complementary function yc can be written as e power alpha x into c1 cos beta x plus c2 sin beta x. Now here we substitute alpha as well as beta. Alpha is nothing but 0x into c1 cos beta is nothing but 1 into x plus c2 sin beta is nothing but 1 into x is x. So I can write in the last step, that is c1 cos x plus c2 sin x. This is nothing but yc. After finding yc, now we have to come for particular integral. Particular integral is equal to yp is equal to 1 upon f of d, 1 upon f of d into x. So here 1 upon f of d is nothing but, you can see here f of d is nothing but d square plus 1. So I can write here this is equal to d square plus 1 into cosec x. Okay, so after writing that, this is can be 1 upon d square plus 1 can be written as 1 upon d plus I into d minus I. Now when you multiply d plus I into d minus I, you get d square plus 1 into cosec x. Okay, so I'll show you here how we get d plus I into d minus I. If you multiply, how we get d square plus 1. So you can see d into d is d square, d into I is nothing but minus di, okay, then plus di, then minus into minus into plus is minus, I into I is I square. Okay, so plus di minus di get cancels, so this is equal to d square minus I square is nothing but minus 1, so this is equal to d square I minus into minus plus 1. So you can see in the denominator, in the place of d square plus 1, I am writing here d plus I into d minus I. So after writing d plus I into d minus I, now in the next step we write this is equal to, now by using partial fraction you can take a upon d plus I plus b upon d minus I, then you can find by partial fraction, or else you can find 1 upon 2I into, you can write 1 upon d minus I minus 1 upon d plus I into cosec x. This can be found by using partial fraction. As you know how to find partial fraction, this is this I can write in the form of a upon d plus I plus b upon d minus I in bracket, and then we have cosec x. Okay, so now you use partial fraction to find capital A and capital B. So after finding capital A and capital B, we get this step. Okay, so after getting this step, if you want, I can solve in next page after this problem how to find A and B by using partial fraction. I'll show you how you got this one. Okay, so this is A, capital A and capital B. After finding, you get this. Okay, so after this, now this can be written as, this is equal to this. Okay, this is equal to now next step we will get 1 upon 2I in bracket. I am multiplying with cosec x inside, so that it becomes 1 upon d minus I cosec x minus 1 upon d plus I cosec x. Okay, so this you get. After this we take separately this term, and then we solve now so that you can understand. So he is saying how you got d square plus I. D square plus I we won't get any here. Here we got only, here d square plus 1 is there, that we have taken here, and then this d square plus 1 can be written as d plus I into d minus I. I have shown you here how you can write d square plus 1 as d plus I into d minus I. I have solved here so that you can understand. And then after this we have to write this in terms of partial fraction, that is nothing but here we have two terms, so I have written a, capital A upon d plus I plus capital B upon d minus I cosec x. After that I have multiplied cosec x inside, so that I mean here we have got I have used partial fraction for finding A and B, so that we got this one. So we got this A and B values, so that you got the step here, and then after that we are multiplying cosec x inside, so that the step will become in this way. So after this, let us go for next step. So in the next step, now here you can see we have two terms, this term and this term. So first I am finding this term, now, and then I find this term. So for finding that term, I write here now 1 upon d minus I into cosec x is equal to, now I can write this is equal to e power ix integral e power minus ix cosec x dx, because Here in the procedure you have seen here, when you have a upon 1 minus d minus 1, you have to write in this way. Okay, because in this problem a is nothing but 1 here, isn't it? A is nothing but 1 upon d minus m1 into x. In the procedure it is given, you can see in the procedure it is a1 into 1 upon m1. a1 we got 1 here, so 1 upon 1 minus m1 is I here into capital X. Capital X is nothing but cosec x here. So if it is cosec x, you can see in the problem 1 upon d minus m1 into cosec x. So if it is the case, then according to the procedure we can write a into e power m1x integral capital X e power minus m1x. Okay, so that I am writing here, you can see as per the procedure. Now a is 1, then e power m1 is I here in our problem, m1x, then integral, we have written integral, x is capital X is nothing but cosec x, e power minus m1 is I again from our problem here, then into x. So we are finding this first. So then here I can write this is equal to e power ix integral, as you all know, you have studied in your intermediate, e power minus ix can be written as, I am writing cosec x first here, and then e power minus ix is nothing but cos x minus I sin x dx. Okay, here I am writing, since e power minus ix is equal to cos x minus I sin x. Okay, so in the place of e power minus ix, I have written cos x minus I sin x. After writing that, in the next step I can write this is equal to e power ix integral. Now I multiply this cosec x inside, that becomes cosec x into cos x minus cosec x. I can write I first, I cosec x sin x, okay, put in bracket dx. After this you can write this is equal to e power ix integral, cosec x can be written as 1 by sin x into cos x minus I into 1 by sin x into sin x, okay, put the bracket dx. Now in the next step you can see this is equal to e power ix integral of cos x by sin x is nothing but cot x minus, you can cancel sin, you get I in bracket dx. Okay, now this is equal to e power ix integral, here we write separately. Now I just put the bracket here, cot x dx minus, I write integral of I dx, just close the bracket now. Then in the next step you get e power ix. Now integral of cot x is nothing but in bracket log sin x minus, I is constant here, we have I constant, if you take it outside, integral of 1 dx is x, so I can write ix. So now we replace I with minus I, this is nothing but we got for this is the term we got for 1 upon d minus I cosec x is equal to, we got this 1 e power ix in bracket log sin x minus ix. Now for finding, here you can take this as equation 1. So for finding now, for because you can see in the problem we got 1 upon d minus I cosec x and then 1 upon d plus I cosec x. We got this. Now we have to find this one. For finding that 1 upon d plus I cosec x is equal to, we can write e power minus I x. That can be, because we are here, you can see we can just replace I by minus I, so that the answer will be, I am not doing here, I am writing directly by replacing I by minus I. So log x log sin x plus ix. So here I am writing just replacing I with minus I. Your work is you have to do at home, as just now we did 1 upon d minus I cosec x. We have used the procedure, we have written the procedure, all this thing we have done. In the same way we have to do, you have to do at home 1 upon d plus I cosec x. You get this answer. As directly we can take replacing I with minus I, we will get the same answer. When you do all this, you get the same answer, or else if you replace just I with minus I, you will get the same answer. So after getting this will be, can be written as yp is equal to, we have to add this both, whatever answers you got. So we have 1 upon 2I, we have not taken this one, just here you can see this is left here, so just we have taken this separately, we have find. So 1 upon 2I is there, so 1 upon 2I we are taking, then into, so we got the answer, first answer is e power ix into log x log sin x minus ix, minus, because why I am taking minus here, because here we have in the problem, in the last step it was minus here, so we are taking minus e power minus ix in bracket log sin x plus ix. Okay, so this is the answer you get. This is nothing but the particular integral. Okay, hope you have understood. In this way we do case 5. So I'll give you one homework problem for you. You just take down this problem and do at home. If it is so if you are getting, I mean if you can solve, do it, or else just post your answer in the WhatsApp if you are getting this problem or not, so that I can do in next class, or else I'll do and I'll post in the WhatsApp the solution of this one. The problem is solve d square plus a square into y secant ax. Okay, so this problem you have to do the same way which I have done just now. Okay, so I'll write the answer. The answer you get is yp is equal to 1 upon 2ai in bracket e power iax into x minus I by a log secant ax bracket close, then minus e power minus iax, and in bracket you get x plus I by a log in bracket secant ax bracket close. So this is the answer you get. You do at home, you practice it, so that you can do the problem. So in the same way which I have done in this problem, you have to do this problem also. So you can take this as homework. You try it and post the answer in the WhatsApp, so that I can check. If you are unable to do, you just reply me in WhatsApp, I can send you the answer. So this is about case 5. So hope you have understood. So tomorrow I can do another 2 topics are left in this unit. If I can complete it tomorrow, so then I'll tell you the procedure of the internal exam tomorrow. So you attend tomorrow's class and Mostly I'll send you the what are the questions we are getting with the internal exam, how it will be. Okay, thank you. You can post your attendance. Those who have not posted, they can post. Don't post your attendance twice or thrice. Thank you very much.